In this video, I'm going to complete the Edexcel higher tier paper 1 non-calculator from November 2018. Question 1. Work out the value of 3 to the power of 7 multiplied by 3 to the power of -2 over 3 cubed. So if we do the top line first, when we multiply indices, we add the powers. So we're going to do 7 plus -2, which is 7 minus 2, which is 5. So we've got 3 to the power of 5 divided by 3 to the power of 3. And when we divide indices, we subtract the powers. So 5 take away 3, which is 2. So we've got 3 squared. And 3 squared is 3 times 3, which is 9. Question 2. So we're given v squared equals u squared plus 2as, and we're told u is 12, a is -3, and s is 18. And we need to work out the value of v. So we're just going to substitute u, a, and s in. So it gives us v squared equals 12 squared plus 2 times -3 times 18. So 12 squared is 144. If we do the -3 times 18 first, 3 lots of 18 is 3 lots of 10, which is 30, and 3 lots of 8, which is 24. So 54, and it's a positive times a negative, positive times a negative, so -54. Then we'll do 2 times -54, which is a negative, and it's double 54, which is 108. So we've got 144 take away 108, take away 100, that's 44, take away 8, 36. So v squared is 36. So v is the positive or negative square root of 36, which is 6 or -6. It says work out a value of v. So we only need one of those answers. So if you didn't put the negative answer, that's absolutely fine for this question. Part B, make S the subject of v squared equals u squared plus 2as. So that means get S by itself, make the equation or make the formula S equals. So if I subtract u from both sides, I can have v squared minus u squared is 2as. And then if I divide both sides by 2a, at the moment s is multiplied by 2a. To get rid of it, we do the opposite. So we divide both sides by 2a. So we've got v squared minus u squared over 2a is equal to s. So s is the subject, and that is our answer. So v squared minus u squared over 2a. Question 3. A bonus of £2,100 is shared by 10 people who work for a company. 40% of the bonus is shared equally between 3 managers, and the rest of the bonus is shared equally between 7 salesmen. So they get 60%. One of the salesmen says, if the bonus is shared equally between all 10 people, I will get 25% more money. Is the salesman correct? You must show how you get your answer. So we need to work out how much the salesman gets at the moment, or the salesman gets at the moment, and then how much you'd get if all 10 people shared equally. So at the moment, 60% of 2,100, so 60%, so 50% of 2,100 is half of 2,100, which is £1,050. 10% of 2,100 is 2,100 divided by 10, which is 210. So 60% is these two added together, which is £1,260. So that's 60%, and that's shared between 7 of them. So this divided by 7, how many 7s going to 1,260? None into 1, 1 into 12, with 5 left over, and 8 going to 56. So they get £180 each at the moment. If all 10 people shared equally, that will be 2,100 divided by 10, which should be 210. So £30 more. Is that 25%? So we can work out what percentage 30 is of 180. Or we could work out what 25% of 180 is. So 50% of 180 is 90. 25% is £45. So he's not going to get £45 more. He's not getting 25% more. He's getting £30 more. So no, £30 is not 25%. Question 4. It would take 120 minutes to fill a swimming pool using water from 5 taps. How many minutes would it take to fill the pool if only 3 of the taps are used? So if we multiply 120 by 5, which is 600, that's how many minutes it would take for 1 tap. So 600 minutes for 1 tap, and if we divide that by 3, so we need 600 minutes of flow of water to fill this swimming pool. So 600 shared out between 3 taps will give us 200 minutes for each of the 3 taps. Part B, state one assumption you made in working out your answer to part A. So we assumed that each tap flows at exactly the same rate. So each tap has the same rate of water flow. Question 5. A plane travels at a speed of 213 miles per hour. Work out an estimate for the number of seconds the plane takes to travel 1 mile. So it goes 213 miles in 1 hour. And because we're allowed to make an estimate, we can round 213 to 200, one significant figure, or the nearest hundred. So 200 miles, approximately 200 miles in 1 hour. And we need to know how many seconds, so we're going to change hours into seconds, it takes to travel 1 mile. So how many seconds in an hour? Well, there's 60 minutes in an hour. And in each minute, there are 60 seconds. So 60 times 60. 3,600 seconds. So 1 hour is the same as 3,600 seconds. So it goes 200 miles in 3,600 seconds. So how long for 1 mile? So we're going to divide by 200. We can do it in 2 steps. So if we divide by 100 first, 2 miles in 36 seconds. So 1 mile in 18 seconds. So it takes approximately 18 seconds to travel 1 mile. Is your answer an underestimate or an overestimate? So what did we round? We rounded the distance down. So the distance is actually more than 1 mile. So it goes more than 1 mile in 18 seconds, which will mean it takes less than 18 seconds to travel 1 mile. So it's an overestimate. It's actually going to be less than 18 seconds, the real answer. So it's an overestimate. We rounded distance down, so the time would be less. Question 6. Solve the simultaneous equations. So we've got 5x plus y equals 21 and x minus 3y equals 9. So we're going to solve them by elimination. So we're going to make either the x's the same or the y's the same. I'm going to make the x's the same. So I'm going to leave the top line as it is and multiply the bottom line by 5. So I've got 5x plus y equals 21. And I'm going to multiply the bottom line by 5. So I've got 5x minus 15y equals 45. So I've got 5x and 5x. To get rid of them, I'm going to take away 5x, take away 5x is nothing. So 5x take away 5x is nothing. 1y minus 15y. So 1y plus 15y is 16y. And 21 take away 45 is negative 24. So y is going to be equal to negative 24 divided by 16. Going to simplify that. They're both in the 8 times table. So it's negative 3 over 2. Or we could write that as negative 1.5. Either way is okay. So I've worked out y. I'm going to work out x now. And I'm going to substitute my y answer back into the top equation. So I've got 5x plus y, which is minus 1.5. So I'm going to write minus 1.5 equals 21. So I'm going to solve this equation now. So we're going to plus 1.5 to both sides. So 5x equals 22.5. And then divide both sides by 5 to get x by itself. 22.5 over 5. How many 5s go into 22.5? 4 whole ones. And I've got 2.5 left, which is half of a 5. So it's 4.5 for x. So x is 4.5 and y is minus 1.5. Question 7. The diagram shows a square ABCD with sides of length 20 centimeters. It also shows a semicircle, so the white bit down the bottom, and an arc of a circle, so a quarter of a circle, which is the shaded bit, but with the semicircle cut out of it. AB is the diameter of the semicircle. AC is an arc of a circle with centre B. It's a quarter of a circle, centre B. And we need to show that the area of the shaded region over the area of the square is equal to pi over 8. So we need to work out the area of the shaded region and the area of the square, then put 1 over the other one. So, well, we could do the area of the square first. So it's 20 by 20, 20 times 20, which is 2 times 2, with 2 zeros on. So we've got 400 centimeters squared for the square. And the area of a circle is pi times the radius squared. So for our semicircle, it's going to be pi times the radius squared over 2, because it's half of a circle. So the semicircle, the area is pi times the radius. So the diameter is 20, so the radius is 10, over 2, because it's only half of the circle. And 10 squared is 100. 100 times pi is just 100 pi. And then half of that, 50 pi. So that's a semicircle. How about the quarter of a circle? So for this quarter of a circle, the radius is 20. We've got a quarter circle. Pi times the radius squared. We've only got a quarter, so divide by 4. 20 squared is 400 times pi, 400 pi over 4. 400 pi over 4 is 100 pi. So the shaded area is the quarter circle. Take away the semicircle. So shaded region, the quarter circle, take away the semicircle, and that is 50 pi. So the area of the shaded region over the area of the square should equal pi over 8. So the area of the shaded region is 50 pi. The area of the square is 400. And 50 and 400 are both in the 50 times table. So I divide the top by 50, divide the bottom by 50, and that gives us pi over 8. Question 8. Write down the exact value of tan 45. Tan 45 is 1. Here is a right-angled triangle. So we've got a SOHCAHTOA question. Cos 60 is 0.5. So they're telling us what cos 60 is. So we just need to answer the question. So we've got the hypotenuse, which is the longest side. The opposite is opposite the angle. And the adjacent is in between the angle we're given, or the angle we're using, and the right angle. So we're not using the opposite. We're using H and A. So which one's got H and A in it? Well, that's cos, which we already knew because we've been told that cos 60 is equal to 0.5. So cos with the angle equals adjacent over hypotenuse. That means cos 60 is equal to 4 over x. And we know that cos 60 is 0.5. So we can change cos 60 into 0.5. So 0.5 is equal to 4 over x. How do we get x by itself? So we multiply both sides by x. So that will give us 0.5x equals 4. And then divide both sides by 0.5. 4 over 0.5. How many halves go into 4? That's 8. Question 9. The times that 48 trains left the station on Monday were recorded. We've got a cumulative frequency graph giving us information about the number of minutes the trains were delayed, correct to the nearest minute. So here's our cumulative frequency graph. What do we need to know? We're going to draw a box plot. So for a box plot, we need the shortest delay, which we've got, the longest delay, which we've got, and we need to work out the median, the lower quartile, and the upper quartile. So we'll go back to our cumulative frequency. There are 48 trains. So for the median, we're going to look at 24, halfway, 24 trains, the 24th train. So we'll go from 24 to our line, and then down. So our median is going to be 10. And for our quartiles, we're going to have, well, 1/4 of 48 is 48 over 4, which is 12. So our lower quartile is going to be at 12. So our lower quartile is going to be 4 minutes, and 3/4 of 48, that's going to be 36. So we'll go for 36. Which is at 20. So we should have all the information we need. So we've got our lower quartile at 4, our median at 10, and our upper quartile at 20. So we just draw these lines on now. So we've got 0 minutes, 4 minutes, 10 minutes, 20 minutes, and 42 minutes. And we join the middle 3 up with a box and join 2 whiskers, 2 lines out to the lowest and highest values. And that is our box plot. 48 trains left the station on Tuesday. The box plot gives information about the delays on Tuesday. and we're going to be asked to compare them. Compare the distribution of delays on Monday and Tuesday. So when we're asked to compare box plots, we compare the median and we compare a measure of spread. So compare the median and compare the interquartile range. So the median delay was higher on Monday, and on Monday they were also more spread out. So the interquartile range, the gap between the lower quartile and upper quartile, and the range, the gap between the lowest and highest, was bigger. So on Monday, the median was higher and the spread was higher. So on Monday, the median delay was longer, and also on Monday, the spread of delays, so how spread out the delays were, was bigger or wider. So it had a bigger interquartile range and a bigger range. Part C. Mary says the longest delay on Tuesday was 33 minutes. This means that there must be some delays of between 25 and 30 minutes. Is Mary right? You must give a reason for your answer. So the longest delay is 33, and this means there must be delays of between 25 and 30. So the longest delay is 33, and the upper quartile is at 17. So we've got no idea if there are any delays between 25 and 30. So no, Mary's not right, because all of the delays could have been between 17 and 20 and 25 and 33. So no, Mary isn't right, because we don't know. We don't know when those delays were. We don't know the individual delays. Between the upper quartile and highest value. There could be none between 25 and 30. Question 10a. Simplify. So we've got an algebraic fraction. So we've got x minus 1 on top. And we've got 5 times x minus 1 squared, which is x minus 1 times x minus 1 on the bottom. So we can cancel x minus 1 from the top and the bottom. So what will be left on the top? Well, it's 1. So we've got 1 times x minus 1 on top. And if we cancel the x minus 1, we've just got 1 left. So we've got 1 over 5 times x minus 1. Part B, factorise fully. 50 minus 2y squared. So how can I factorise this? Well, to start with, 50 and 2 are both even, so I can take 2 outside the bracket, both in the 2 times table. So I've got 2 on the outside 2 times 25 makes 50, and 2 times y squared makes 2y squared. So I factorized it. I haven't factorized it fully because I can factorize the bracket again. So this is one to recognize. It's a difference of 2 squares. So 25 and y squared are both square numbers with a minus in the middle. So I can factorize them as 5 plus y and 5 minus y. So the difference of 2 squares, 2 square numbers with a minus in the middle, and that factorizes to 5 plus y and 5 minus y. So now I've factorized fully. There's my answer. Question 11. Jack and Sadia work for a company that sells boxes of breakfast cereal. The company wants to have a special offer. Here is Jack's idea for the special offer. Put 25% more cereal into each box and do not change the price. And Sadia's idea, reduce the price and do not change the amount of cereal. Sadia wants her idea to give the same value for money as Jack's idea. By what percentage does she need to reduce the price? So we're going to get, we've got C, amount of cereal, for P, price. So if Jack increases the amount of cereal by 25%, Jack's going to offer 1.25 times the amount of cereal for the same price. And Sadia wants to know, to change the price and not the cereal, how can you keep this offer the same value? So for Sadia, we need to keep this offer the same value, but keep the amount of cereal the same and change the price. So if we take Jack's offer and divide both by 1.25, so 1.25 over 1.25, that means we keep the same amount of cereal. And how about the price? So it's the price divided by 1.25. So what percentage changes that? So it's 1 over 1.25, which is the same if I double them, 2 over 2.5. And if I times them by 4, that's 8/10. So 8/10 of the price, which is 80% of the price. So by what percentage does she need to reduce it? She reduces it by 20%. To go from 100% to 80%, we reduce by 20%. Question 12. So we've got a circle theorem question here. Just check all the information is on the diagram. So A, B, and C are points on the circumference of a circle, center O. DAE is a tangent to the circle A. Angle BAE is 56. And CBO is 35. Work out the size of angle CAO. You must show your working. So CAO. So this is the one we're working out. And we're going to show all of our working. So when we see a triangle in a circle and we've got a tangent, we can think of the alternate segment theorem. So this 56-degree angle here is the same as this one here. So angle ACB is 56, and I'll make a note of this because of the alternate segment theorem. Then what we can do here is we can cut our angle 56 in half. So when we've got two tangents, when we've got two radiuses, we know we've got an isosceles triangle. So this is a radius, this is a radius. So we've got an isosceles triangle, and the angles at the base of an isosceles triangle are equal. So we know that DCO is 35 degrees, because the angles at the base of an isosceles triangle are equal. So if we've got 56 for the whole angle here, 35 for part of it, we can work out the other part, which is 56 take away 35, which will be 21 degrees. So ACO is 21. And we've got another isosceles triangle. Again, two radiuses means we've got an isosceles triangle. Two lengths the same. The two angles at the base are the same. So x equals 21. And again, because the angles at the base of an isosceles triangle are equal. Question 13. Describe fully the single transformation that maps triangle A onto triangle B. So the big triangle onto the little one, and it's going to be an enlargement. It's going to be a negative enlargement. So we can match up each of the points, each of the corners of the triangles to find the center. So the center's at 2, 2. So it's an enlargement. The center's at 2, 2. And then what's the scale factor? So it's gone from 3 on the shorter length to 1. So the scale factor is negative, because it's gone all the way through the center of enlargement, negative 1/3. So it's a third of the size, and it's gone backwards. So it's negative 1/3. So it's an enlargement. The scale factor is a negative 1/3, and the center was at 2, 2. So that's the information we need to describe a enlargement, that it's an enlargement, the scale factor, and the center. Question 14. Work out the value of 16/81 to the power of 3/4. So we've got a fourth root and cube. So we need to do the fourth root and cube. We could cube first and then do the fourth root, but that would be a lot harder. So we'll do the fourth root first. And what times itself 4 times gives us 16. That's 2. 2 times 2 times 2 times 2 is 16. And for 81, that's 3 times 3 times 3 times 3. So the fourth root first, and then cube it. So 2 cubed, 2 times 2 times 2 is 8, and 3 cubed, 3 times 3 times 3 is 27. Part B. So we've got work out the value of a plus b plus c, and we need to work out what power a, what number a, b, and c are, and then add them together. So we're told 3 to the power of a is 1/9. 9 is 3 squared. So 1 over 3 squared. And to flip it over, it becomes a negative. So 3 to the power of a is 3 to the power of -2, which means a must be -2. And for b, 3 to the power of b is 9 times √3. 9 is 3 squared, and √3, the square root, is the power of a half. So 3 squared times 3 to the power of a half. When we multiply indices, we add the powers. So 3 to the power of 2 plus a half, 2.5. So b is 2.5. And c, 3 to the power of c is 1 over √3. Again, √3 is 3 to the power of a half. And to flip it over, it becomes negative. So 3 to the power of minus a half. So c is minus a half. So a plus b plus c, -2 plus 2.5 minus a half. So -2 plus 2.5 is half. Take away a half is 0. Question 15. 3 solid shapes, A, B, and C, are similar. The surface area of A is 4 centimeters squared. The surface area of B is 25 centimeters squared. And the ratio of the volume of B to the volume of C is 27 to 64. Work out the ratio of the height of A to C. So we've got area of A to B is 4 to 25. So that's the scale factor for area. To get the scale factor for length, we square root. So that's 2 to 5. So the scale factor for length of A to B is 2 to 5. And for volume of B to C, we've got a ratio of 27 to 64. The scale factor for volume is scale factor cubed. So to go to length for B to C, we need to cube root. So the cube root of 27 is 3. The cube root of 64 is 4. So we've got the scale factors for A to B is 2 to 5. And B to C is 3 to 4. So we need to make them the same. So to get them in the same ratio, we need the B's to be the same. So if we times this one by 3 and times this one by 5. So for A to B, we're going to have 6 to 15. And for B to C, 15 to 20. So that means we can put the two ratios together. Now we've made the B's the same. So the ratio of A to B to C is 6 to 15 to 20. what was the question? Work out the ratio of A to C. So A to C, so we don't need B. A to C is 6 to 20, and simplified 3 to 10. Question 16. Prove algebraically that 0.256 recurring, so 0.2565656, can be written as 127 over 495. So we've got 0.256, it's a 56 recurring, and we're going to call that x. So if we want two things ending in the 56 recurring, so if we multiply by 10, we'll get 2.56 recurring. And then if we multiply that by another 100, so we want 256.56 recurring. So that would be 1,000 times the original, 1,000 x's to get 256.56 recurring. And then we've got two things that end in the 56 recurring, so we can take them away. 1,000 x's take away 10 x's is 990 x's, and 256.56 take away 2.56 is 254. The 5 6's recurring all cancel out, and we're just left with 254. Then we're going to divide both sides by 990. And then if we half top and bottom, we get to what we wanted. Question 17. Here is a sketch of a curve. The equation is y equals x squared plus ax plus b, where a and b are integers, and we're told that the points 0 minus 5, and 5, 0 lie on the curve. Find the coordinates of the turning point of the curve. So the turning point is where the curve turns, which is the minimum point, the bottom. So we can use these coordinates, substitute them in, and that will tell us the equation. And then once we've got the equation, we can work out the turning point. So let's start with the first one, 0 minus 5. So we're just going to substitute them in. So substitute in 0 minus 5. So x is 0, y is minus 5. So minus 5 equals 0 squared, which is nothing, plus a times nothing, which is nothing, and that's b. So b is negative 5. So we've got y equals x squared plus ax minus 5. And if we substitute in 5, 0 now, so x is 5 and y is 0, we should be able to work out a. So we've got 0 equals 5 squared plus a times 5, take away 5. So 0 equals 25 plus 5a minus 5. So 25 minus 5 is 20. If we subtract 20 from both sides, negative 20 equals 5a. Divide both sides by 5, so a is negative 4. So the equation now, we know a and b, so we've got y equals x squared minus 4x minus 5. So now we just need to work out the turning point. So we can do this by completing the square. So let's do that. So to complete the square, we half the middle number. So 4, so that's going to be a 2. So we're going to have x minus 2 squared. Take away 2 squared, which is 4. And we've still got the minus 5 on the end. So y equals x minus 2 squared minus 9. And that tells us the minimum point. What makes the bracket 0? That's when x is 2. And what's left when the bracket 0? Minus 9. So the turning point is 2 and negative 9. Question 18. The graph of y equals f of x is shown on the grid. And they want us to sketch the graph of y equals f of x minus 2. So when we've got a change inside the bracket, it does the opposite to what it's told. So it's saying minus 2. So it's changing the x's. Inside the bracket changes the x's and does the opposite. So it's saying minus 2. So we need to plus 2 to all the x coordinates. So if we plus 2 on to all the x coordinates, we should get a graph that's shaped like this. And there's our graph. Here's another one. So on the grid, graph A has been reflected to give graph B. The equation of the original graph is y equals g of x. What's the equation of the new graph? So when we reflect in the y-axis, that's a change to the x coordinates. So it's inside the bracket. So a reflection in the y-axis is a change inside the bracket, and it's g of minus x. Inside the bracket, a minus inside the bracket reflects in the y-axis. A minus in front of the g outside the bracket will reflect in the x-axis. So all the x coordinates have changed. They've gone from either positive to negative or negative to positive. Inside the bracket changes the x. So our answer is y equals g of minus x. Question 19. For all values of x, f of x equals x plus 1 all squared, and g of x equals 2 times x minus 1. Show that gfx equals 2x times x plus 2. So we're substituting f of x into g. So we're taking the whole of f of x and substituting it in to g. So we're going to take all of this, x plus 1 all squared, and put it into our g. So let's see what we get. So gfx is going to be 2 times open bracket x plus 1 squared minus 1 close the bracket. So I've just changed the x into x plus 1 all squared. And we'll just simplify this and see what we get. So x plus 1 squared is x plus 1 times x plus 1, which is x squared plus x plus 1, and we've still got a minus 1. So simplifying, we've got x squared plus 2x, and plus 1 minus 1 cancel. And that's not quite what they've got. So we're going to factorize out both of the terms inside the bracket. I've got an x in them, so we can take the x outside the bracket. So that'd be 2x outside and x plus 2 inside. Okay, part B, find g minus 1 of 7. So the inverse function of g with 7 substituted into it. So g of x is 2 times x minus 1. So g of x is 2 times x minus 1. And if I expand that first, so 2 times x is 2x, 2 times 1 is 2. So we're going to look for the opposite function, the function that does the opposite thing, to times him by 2 and then taking away 2. So one way of doing this is to write it as y equals 2x minus 2. And if we flip the x and y around, so change x and y around, and then rearrange it to make it y equals again. So if we plus 2 to both sides, we'll get x plus 2 equals 2y. And then divide both sides by 2. X plus 2 over 2 equals y. So the inverse function, g minus 1 of x, is x plus 2 over 2. So the opposite of times him by 2 then taken away 2 is adding 2 then dividing by 2. And we're going to substitute 7 into this. So it's 7 plus 2 over 2, which is 9 over 2, or 4.5. Question 20. Show that root 18 plus root 2 all squared over root 8 minus 2 can be written in the form a into b plus root 2, where a and b are integers. So the first thing I want to do here, I see root 18 and root 8. I want to simplify them. So root 18 can be simplified because it is root 9 times root 2, which is the same as 3 lots of root 2. And the same for root 8. Root 8 is root 4 times root 2, and root 4 is 2, so it's the same as 2 root 2. So I'm going to change them to start with. So I'm going to have 3 root 2 plus root 2 squared on top, which is 4 root 2, over 2 root 2 minus 2 on the bottom. So I've got 4 root 2 squared on top over 2 root 2 minus 2 on the bottom. And I can square the top as well. 4 root 2 times 4 root 2. 4 root 2 times 4 root 2. 4 times 4 is 16. Root 2 times root 2 is 2. So 16 times 2 is 32. So I've got 32 over 2 root 2 minus 2. And now what I want to do is called rationalizing the denominator. So to get rid of the third from the bottom, I'm going to multiply top and bottom. So to keep a fraction the same, we've got to multiply top and bottom by the same thing. And I'm going to multiply it by 2 root 2 plus 2. So the same as the bottom, just for a different sign. So that's going to get rid of the third. And I just need to expand these brackets now. So for the top line, 32 times 2 root 2 is going to be 64 root 2. And 32 times 2 is 64. and the bottom, 2 root 2 times 2 root 2. 2 times 2 is 4, and root 2 times root 2 is 2. 4 times 2 is 8. I've got 2 root 2 times 2, which is 4 root 2. Negative 2 times 2 root 2, which is negative 4 root 2. So these are going to cancel. And negative 2 times 2, negative 4. So what have I got on the bottom line now? I've got 8 take away 4, which is 4. And 4 root 2 take away 4 root 2, which is nothing. So it's just 4 on the bottom. I can divide the numbers on the top by 4. So that gives me 16 root 2 plus 16. And what did the question want? So it wants me to factorize. So I can take 16 out of both of the terms on the top. 16 times root 2 makes 16 root 2. And 16 times 1 makes 16. So there's my answer. Question 21. OAB is a triangle. OPM and APN. OPM and APN are straight lines. M is the midpoint of AB. O to A is called A. O to B is called B. O to P is 3 parts. P to M is 2 parts. So we'll call it 3/5 and 2/5. Work out the ratio O to N to B. Let's just work out what we can. So let's go A to B first. So A to B is going to be minus A plus B. And A to M is a midpoint, is going to be half of minus A plus B. We can then work out O to P. So O to P is, well, we'll go O to M first. O to M is A plus A to M, which is half of minus A plus B. And we'll expand this. So A minus half of an A plus half a B, which is half an A plus half a B. So that's O to M. O to P is 3/5 of that. So 3/5 of half an A plus half a B, which is 3/10 A and 3/10 B. A to P is going to be a negative A plus O to P, what I just worked out. So negative A plus O to P. So negative A plus 3/10 of an A plus 3/10 of a B, which is 3/10 take away a whole is minus 7/10 of an A plus 3/10 of a B. So I've got A to P, and I know N is an extension of that line. So A to N is an extension of a to p. So I'm going to call it x times a to p. So that's a to n. And a to n is also, so another way of getting from a to n would be to go minus a plus a multiple of b. So minus a, I've used x already, I'll use y. So I've got two roots for a to n. I can either go down to O and across, or straight down through P. So I've got two different routes, here and here. So they must be equal to each other. They are both a to n. They must be equal. So I can say that this top one, the top one must equal the bottom one. So if I expand this with the x first, xa plus 3/10 xb equals minus a plus yb. And then what I can do, I can look at the a's and b's separately. So the a's must be equal and the b's must be equal. So if I just look at the a's, I've got minus 7/10 x on the left side. That's all I've got. And on the right side, how many a's have I got? I've got -1. So x is multiply by 10 and divide by -7. So multiply by 10 is -10. -10 divided by -7. The negatives cancel. X is 10/7. And then I look at the b's. So on the left side, I've got 3/10 x. And on the right side, I have y. And I know x is 10/7. So I've got 3/10 times 10/7, which is 3/7. So y is 3/7. So what have I just worked out? Well, when I said a to n was minus an a plus y over b, I have worked out that O to n is 3/7 of the total journey here. So if this is 3/7, this side must be 4/7, and the ratio is 3 to 4. So the ratio is 3 to 4. Question 22. There are only green pens and blue pens in a box. There are 3 more blue pens than green pens. So if green pens is x, blue pens is x plus 3. There are more than 12 pens in the box. Simon is going to take at random 2 pens from the box. The probability he takes 2 pens of the same colour is 27 over 55. Work out the number of green pens in the box. So work out x. So how many pens are there in total? So there's x green, x plus 3 blue. So 2x plus 3 pens in total to start with. So the probability of getting green then green So 2 pens are the same colour, so we'll work out green then green, and blue then blue. So the probability of a green then a green, so for the first pen, it's x over 2x plus 3. And for the second pen, we're removing a pen. So 1 less green and 1 less in total. So x minus 1 over 2x plus 2. And for blue then blue, there were x plus 3 to start with, out of 2x plus 3 in total. And if I removed 1, it will be x plus 2 over 2x plus 2. So I can simplify these. Just write it as one line. So x plus 3 times x plus 2. When multiplying fractions, just multiply the top and the bottom. Okay, so there's the probability of green, green, and blue, blue. So the probability of green, green, or blue, blue is 27 over 55. So that's these two added together. So x times x minus 1 over 2x plus 3 times 2x plus 2 plus x plus 3 times x plus 2 over 2x plus 3 times 2x plus 2 is equal to 27 over 55. So their denominators are the same, so we can just add these fractions. So if I expand the brackets as I go, so x times x is x squared, x times negative 1 is negative x, x times x is x squared, x times 2 is 2x, 3 times x is 3x, and 3 times 2 is 6. And the denominator, I'll expand that as well. So 2x times 2x is 4x squared, 2x times 2 is 4x, 3 times 2x is 6x, and 2 times 3 is 6. And that equals 27 over 55. And we'll simplify these now. So the top line, x squareds, I've got 2x squareds, x squared plus x squared. I've got 2x plus 3x minus 1x, which is 4x, and a 6 on top. And on the bottom, I've got 4x squareds plus 10x plus a 6. And that's equal to 27 over 55. I can half top and bottom to make it a little bit easier. So x squared plus 2x plus 3 over 2x squared plus 5x plus 3 equals 27 over 55. And I'm going to multiply both sides by 55 and both sides by 2x squared plus 5x plus 3. So I'm going to get rid of the fractions, which will leave me with 55 times x squared plus 2x plus 3 equals 27 times 2x squared plus 5x plus 3. Expand these brackets. So 55x squared plus 110x plus 165 equals 54x squared plus 135x plus 81. And if I take everything over to the left side, so take away 54x squared from both sides, that's x squared. Take away 135x from both sides. That will be 110 take away 135 is minus 25 x's. And 165 take away 81 will be 84. So I've now got a quadratic. It's equal to 0. So ideally I can factorize this. We should be getting whole number answers. So it should factorize because it's an amount of pens. And what multiplies to make 84 and adds to give a 25? They have negatives, so it's 21 times 4. So x is 21, or x equals 4. And we're told there are more than 12 pens in the box, so x can't be 4, so x must be 21.